Hello Year Nines. This is another of Mrs. Elliott's hand lessons, and today we're going to go back to chapter 6 of the textbook. So we've gone past that. We've already done a little bit of it this year, but we're going to go back to it now and just make sure that we really understand it, and that we can now go back and have a look at some of the slightly harder bits that we skipped earlier in the year. So chapter 6 is all about algebra, and the first bit of it is about formulae. So in your books, could you please write chapter 6.1 formulae and then a title of generating formulae, and we're just going to do a few examples. So you can pause this at any time so that you can write the examples down. So the first one, we're going to think about a theatre. And we're going to say that we know the theatre has n seats, and those are arranged in rows. So in the theatre, it has R rows, and there are 25 seats in each row. Now what I want us to do is to come up with a formula that tells us how many seats there are in total in this theatre, because that's what formulae do. They give us ways of calculating things quickly and easily. So in this theatre, we are going to say we've got n seats, and that is equal to, now think about it, if we had one row, we'd have 1 times 25 seats. If we had 2 rows, we'd have 2 times 25 seats. If we had 3 rows, we'd have 3 times 25 seats. We don't know how many rows there are. We've just called the number of rows R. So we are going to have R times 25 seats. So we can say N equals 25R. That's the number of seats in the theatre. Yeah? So this is a formula for the number of seats in the theatre. Let's do another example. This time we're going to think about a boy, and we'll call him Andrew. And Andrew's age is going to be called A. Now, he has a sister called Betty. Her age, yes, you've guessed it, we're going to call that B. If Andrew is 5 years older than Betty, how can we calculate Andrew's age? Well, we know Betty's age is B, and we know that Andrew is 5 more than B. So Andrew's age is going to be B, Betty's age, plus 5. So that formula gives us Andrew's age, as long as we know Betty's. Last one uses our knowledge of averages a little bit more. That was example 2. Example 3. Let's say that we've got 3 people. And their age, not their ages, their weights are A kilograms, B kilograms, and and C kilograms. We want to know their average weight. What formula could we use for that? Well, we know that to find an average of something, we add everything together and we divide by however many we've got. So in this case, we'll add the weight of person A to the weight of person B to the weight of person C, and we will divide by 3, and that will give us their average weight. So that formula is the formula for the average weight of people. So what we're basically doing when we're generating formulae for ourselves is we are coming up with a mathematical way of describing something that we would usually describe in words. Let's try a slightly harder example. So if you need to at this moment, you could just pause and just make sure you've copied these down. Okay, so I'm going to rub these out. And we're going to have a little bit of a think about a slightly harder example. So a slightly harder example involves a window cleaner. Okay, so window cleaner. Oh, I'm going to call this example. We're on example 4, aren't we? Example 4. So a window cleaner charges a £10 call-out fee. So that's just for turning up, plus £7 for every window cleaned. We're going to say C is the total cost and N is the number of windows cleaned. So we want a formula that finds our total cost for us. So let's think about our total cost. Our total cost is C. Now this window cleaner, regardless of how many windows they clean, is going to charge £10 just for turning up. So even if they turn up and don't clean any windows, they're going to charge us £10. So we've got to include that. And then they're going to charge us £7 for every window cleaned. Now, if they charge us, if they're just cleaning one window, that will be 10 plus 7. If they are doing 2 windows, it will be 10 plus 2 times 7. 3 windows, 10 plus 3 times 7, etc. So the number of windows cleaned is always going to be multiplied by the 7, the cost for each window. And you can see there that that formula works in the way that we've just described, because if n was 0, no windows cleaned, we just pay £10. If n equals 1, so 1 window cleaned, we'd be charged 10 plus 7 times 1, £17 in total. If we've got 5 windows that are being cleaned, it would be 10 plus 5 times 7, 35. 10 plus 35 would be £45. If there was a very, very big house, if n equals 15, so big house with lots of windows, how much would the window cleaner charge? Let's do that as an example. So our example would be C equals £10 call out charge plus 7 times 15. 7 times 15 I think is £105. So in total it'd be 10 plus 105. Quite a lot of money to get your windows cleaned. cost would be £115. So there we've got a scenario where we're told n is 15. We've substituted in a value to find out how much it's going to cost for 15 windows. What about, so I'm going to change this, I'll use a different colour pen. What about if your friend who is using the same window cleaner as you tells you that the cost of cleaning their windows is £94? You could then work out how many windows they had cleaned. You could substitute into your formula. So C equals 10 plus 7n. Your cost, you know, is 94. 94 equals 10 plus 7n. What have we got here? We've got a little equation, haven't we? With numbers on this side and there, and some n's over there. What can we do to get to those values of n? Well, the first thing that we'd need to do is take away 10 from both sides. So if we take away 10 from both sides, we end up with 84 is 7 times n. How many times does 7 go into 84? I think it goes in 12 times. So dividing both sides by 7, 12 equals n. So we've got 12 windows cleaned. That's an example, again, of substituting a value into our formula. So at the beginning of this example, we worked out the formula, C equals 10 plus 7n for this example. And then in these two bits here, we've substituted a number into the formula. So for this one, we substituted in a value for n to work out how much it would cost to have 15 windows cleaned. And here we've said, well, we know our total cost of having our windows cleaned is 94. We're interested in finding out how many windows were cleaned. So here we've substituted in for the C, and that's helped us to find out what our value of n is going to be. Let's just have a go at a couple of formulae that we can substitute into and just practice this skill a little bit more. Okay, so again, if you haven't quite copied all of this down, just take a moment to copy it down now. Pause the video because I'm about to rub it off. Now, I think this could do with just a new little subheading, because this is substituting into a formula. So we'll write that as a subheading. Substituting into a formula. So that's a little subheading for you to write into your notes. And we'll just have a look at a couple of formulae and we'll use them. So I'm going to give you this formula. So we'll call this example 1. The formula that I'm going to give you is D equals 4.9 t squared. Now, what do these mean? D equals the distance in meters. That an object falls. And T equals the time in seconds. So now we're going to see how far does the object fall after different numbers of seconds, or how far does the object fall after, and we'll go for 2 seconds, we go for part B, 3 seconds, and then we'll go up to 5 seconds. Okay, just going to split my page up here for the workings. So this is my formula. I'm going to try and find this distance. How far means what is the distance. And the values that I've got here, the 2 seconds, 3 seconds and 5 seconds, are going to be my values for t. So after 2 seconds, t equals 2. So substituting into my formula, d equals 4.9 t squared, d is going to equal 4.9 times 2 squared. That's 4.9 times 4. Remember, we do our power first. So that's a big mass, isn't it? So we look at our brackets, we look at our power. 2 squared is 4. So it's going to be 4.9 times 4. It's going to be a bit less than 20, I think. 4.9 times 4 is going to be 19.6. It said up here it's a distance in meters. So that's meters. Why don't you pause the video for a second and have a go at t equals 3 and t equals 5 for these two, and see if you get the same values as me. So you're trying to find out how far the object has fallen after 3 seconds and 5 seconds by substituting into the formula. So d equals 4.9 t squared, d equals 4.9 times 3 squared, that's 4.9 times 9, that's 44.1 meters. I'll make that a d equals. And then for t equals 5, d equals 4.9 t squared, so d equals 4.9 times 5 squared, d is 4.9 times 25, so d equals 122.5 meters. Check that you've got the same answers as me for those, and that you're happy using that formula and substituting into it. And we're just going to do one more example. I think we're going to use a formula that you're familiar with this time. So my example is going to be the formula for the area of a trapezium. So let's have a think about that. So formula for the area of a trapezium, example 2. Hopefully you can remember what a trapezium looks like. I usually draw mine looking like this, but they don't always look quite like this. The key thing is they've got 2 parallel sides, and we call those A and B in our formula. And the perpendicular distance between those 2 sides we always call H. And the formula for the area of a trapezium, and you should know this one, and if you don't, it's probably time to learn this one. Area of a trapezium is half of these 2 lengths added together, the 2 parallel sides added together, multiplied by H, the perpendicular distance between them. Now, I am going to tell you that we know the area of a trapezium is equal to 40 centimetres squared. And we know the parallel sides are 7 centimetres and 9 centimetres. What we want to know is what is the height of the trapezium. So we're going to use the formula that we know for the area of a trapezium, and we're going to substitute into it. So there's our formula. So just looking at our diagram here, our area from our question is equal to 40 centimetres squared. Our A and our B, our two parallel sides, we've been told are 7 centimetres and 9 centimetres. So first thing you do is write out your formula. I'm going to use A for area, or capital A for area, is half small a plus small b times h. And now I'm going to fill in what I know. So I know that my area is 40. I know that that's equal to half of my two shorter sides, and my two parallel sides added together, 7 plus 9 times h. I'll do a little working with what I know here. 40 equals half times 16. 7 plus 9 is 16 times h. Half of 16 is 8. So 40 equals 8h. So now to find that height, the thing that I'm missing, I need to divide both sides of this little equation by 8. 5 equals h. So that's the height of my trapezium. So that's an example of taking a formula and substituting into it what you know, and then you're just left with one thing that you don't know, and that's the thing that you are looking for. Okay, gents, I think you are ready for some questions now. So the questions that I'm going to set based on the work that we've done here. So if you haven't copied this down, gents, or actually I'll get another whiteboard. Here we go. If you haven't copied that down yet, pause the DVD. Oh, sorry, not the DVD, the recording, just for a moment. So the work that I'm going to set you based on this is exercise 6.1s from your books. That's on page 105. And the questions you're going to do are question 1, question 4, and question 5. And I would like you to set out your workings in the same way that I've set them out, please. And I would like question 5 to be submitted as evidence, please, that you've done this work. So I want to see question 5 submitted as evidence onto Inside. However you do that, probably by taking a photograph of it and attaching it to Inside. Okay, good.